Hi students.
Hi, sir.
Today I'm going to ask you one question related to Newton's second law. So, if we have an object moving on an inclined system with a different surface, is there an effect when we use a different surface? Yes.
Yes. No.
To give more understanding, I will introduce to you smart plane.
I'm a very pretty little risky baddie 모든 죄대로 되라지 catch me if you can very 나는 없어 거기.
Allow me to walk you through the objectives of this project. Firstly, our goal is to demonstrate the application of Newton's second law of motion by using the smart inclined plane. This allows us to visualize and see how does the law function in real life world scenario. Secondly, our aim is to analyze the multiple forces that is acted on an object that is moving in an incline, such as gravitational force, frictional force, as well as normal force. This helps us to understand deeply and more on the role of each forces in the motion of an object. Lastly, this project would help students to understand Newton's second law of motion a lot more by giving them a chance to use it in an interactive and fun way. So, with these objectives in mind, let us continue.
So, this is our smart plane. The project that we want to know the effect is what effect when we're using different materials, what effect when we're using different angle, and what effect when we're using a different weight. So, this is inclinometer to measure the angle. So, let's restart our project.
Tested how fast an object slides up an inclined plane using 3 different materials, which is aluminium, perspex, and also wood. Perspex was the fastest, which only takes 1.29 seconds for the objects to slide up the plane, followed by aluminium, which only takes 1.7 seconds, while wood was the slowest time taken due to the highest surface friction, which is 2.1 seconds.
As we can see, this table clearly shows how surface type affects the speed of motion, with smoother materials allowing the object to slide faster.
We also tested different incline angles. As the angle increased, the time taken decreased because the gravitational force component became larger.
As the angle gets steeper, the object moves faster, so the time taken becomes shorter.
Mass also played a role as heavy objects increase both the normal force and momentum. It slightly affects the motion.
This table shows how heavier mass make the object slides faster. This is because greater mass increase momentum, helping it overcome friction more easily.
However, the type of surface remain the most influential factor.
Now, I'll be presenting the results of our experiment into frictional forces produced by different materials, aluminium, perspex, and wood, when a car is pulled up a 40-degree incline using a hanger mass. Using Newton's second law, we calculated the friction force each material using this equation, where is the tension from the hanger mass, the component of gravity, and the force due to the car's acceleration. So, here are the calculated friction forces. Aluminium with 0.09, perspex 0.07, and wood 0.10. These values show that wood has the highest friction force, while perspex has the lowest. In conclusion, wood offers the most resistance to motion. It provides the smoothest surface with the least friction. And these results are consistent with the time data and match expected material behavior.
Of course, the prototype that we built has its own limitations, including precision of measurement. Due to sensor limitations, the inclinometer may provide inaccurate measurement. Moreover, since we only use timer to record time, there might be some errors in theory calculation. Moreover, since this mockup is in a small scale, the system may have restrictions on weight of force produced. Next, the surface durability. The surface may wear out over time and it could affect the overall performance of the model. Lastly, to have a continuous power sources, we have no other choices than to depend on a battery. In conclusion, the mock-up have achieved its objective, and however, there might be some improvements that can be made, including to switch to a higher solution in calorimeter for best measurement. Next, bigger scale product can be made so that bigger weight objects can be tested. Lastly, height and alternative materials can be used in the new design so that the surface will not easily burn out after a few times use. That's all.